Hey everybody, this is Larry. This is what am I doing? I didn't even click on the right thing. This is the virtual contest for the bi-weekly. I don't know which one yet. 164. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's contest and everything along with it. This is the live recording. We're looking for explanations. Check out that video. I'm sure you can find it by Googling or whatever. YouTube's. Just getting my notebook ready. Am I ready? I'm okay. I want to do this contest and then go for a 6 mile run, so it should be okay. All right, let's go. Go. Do. All right. Low. All right. That press record. Yep. Just in case. I find the least frequent digit. No. Yeah. I was trying to think whether like there's a thingy for it, but yeah, okay. Yeah. Yeah, I mean, I was trying to say that that there's probably like a function for it in the library, but I was like, maybe I should not look it up. And this looks okay, but actually it's wrong. Almost got that right. Wow. That would have been a very sad wrong answer, actually. But it's also wrong in general because it's 5 and 2. Oh, what the? Okay, well. The other way, yeah. Man, when you're getting that sloppy on a easy, I think some part of getting sloppy is just because I'm trying to do it really fast way. Because obviously, if I just took 1 more minute, it would not be that slow. Okay, let's go. Given deck of cards. Each card displays 2 low counters. Okay, you're given an X, you play a game with the following rules. A letter X, 0, you would find 2 comparable with that contains the letter X. Remove the pair of cards and remove 1 point. What's a compatible card? Oh, you have to okay. Really? Huh. There really was rather n is 10 to the 5th is that part. But this feels like one of those NPE problems, but maybe I'm wrong. Maybe there's a greedy. Because like I feel like you could set this up as like a satisfactory problem. Maybe I'm wrong. Is there greedy? What would the greedy look like? I mean, this one just take everything, right? No, they have to be different one day, so they cannot contain both of them. Oh, I mean, I guess it's bipartite matching actually, so it's not necessarily NP, but bipartite matching is still very expensive, right? I think bipartite matching makes sense. Is it even bipartite? Actually, I mean, it is matching, but I don't know if it's bipartite matching. It's just the number of pairs, right? Yeah, I mean, with 10 to the 5th, what can you do? Honestly, what I wanted to do is like bit mass DP, but obviously 10 to the 5th is not even close. The thing is that they both have to have X. Do they have to have X in the same position? Okay, I mean, I guess there are two cases, right? There's the XX or whatever. That's the tricky case. So maybe that is this is an annoying one though. I feel like this is one of those problems that I would get like 5 wrong answers, missing cases. So okay, so that means that if they're in the same position, then they all map to 1, and then maybe just okay. Because if they differ in the position, they have to differ in the other one to keep an X, right? So okay, so put them in a counter first. Double maybe. I don't know if that's a keyword actually. F of X plus X, right? Otherwise, we just merge. Maybe I wrote this wrong anyway. Yeah, okay, so you have a first is equal to 0, second is equal to 0, so and then D is equal to this, so maybe both 0, maybe that's just a little bit whatever. If word is equal to X plus X, I cannot even write equal correctly. Else if sub 0 is equal to X, so maybe something like this, right? And then now, how do you want to do the math? I guess it's greedy. Well, second and first just matching themselves, right? So it's gonna be return first divided by 2. So you have mod 1 plus second divided by 2. So then now extra is equal to first mod 2 plus second mod 2. Right, something like this. And then now, well, don't want to write both. Okay, so then now both plus extra. No, not because they can't match with each other. So we'll just do greedy then, right? Actually, so again, it's extra is not right. I mean, maybe it's right, but extra this one first. Do you always want to match the both of those? I guess so, right? So yeah, so match is equal to, I think match is also a keyword actually. Main of extra both, extra, I guess this is only 1 or 2 actually, I forgot. Extra, both, count, right? I mean, this can only be 1 anyway, but something like that maybe. And then we do the same thing for a second, right? And maybe copy and paste is terrible. But then now, just whatever's left over, and then that should be good, right? 1 and 0 is not great. Why did I write F? I meant chords. I guess F was the initial frequency, 2, 1, 1. Min both. I misunderstood. No, B, right? So why is this A, B, and AC, I guess? But that doesn't make sense. Huh, okay. Why is it giving me... Second is 3. Oh, I am dumb. Okay. I don't know why, I think I just, yeah. Okay. 210, YOLO go. Yeah, I mean, I'm not surprised that I got a wrong answer here. Huh? Did I misunderstood this one? Oh, it has to be exact, huh? Wow, that makes it so much tougher. I actually misread that. I mean, I don't know if it's so much tougher, but I have to. Well, whatever I did is not wrong. Just misread this altogether. Okay. I hate you. So then this is the whole thing with. It's just so annoying with the thing. Okay, I mean it's not. Yeah, and then it's just so annoying. Okay, I'm just annoyed to be honest. Because it's. I mean, it's not. I don't know if it's hard, but it's just annoying. Especially annoying for me because I have to rewrite a lot of stuff to support it. I mean, it's my fault though, because I probably should have read this clearer. How do I want to write this? Okay. Actually, I don't even know. No, it should be okay. I think the same idea, basic. No, which can no, yeah. I mean, the same idea basically works, and now the both doesn't matter as much anyway. But then first we just have to get max. Right. So okay. So let's just say we have. Okay, fine. And then it's basically the same. No, yeah, basically the same. Okay, so then now let's just say count is equal to 0, right? We want to see what is the okay. So we're gonna get extra is equal to get first, maybe get go first. Let's just say. We want to say f dot max. We only care about max. Right, so okay. Okay, if length of f is equal to 0, just return 0, 0, 0. I'm gonna return pairs and extra. Okay, so then now otherwise it's max, right? We probably need sum of values. Okay, fine. And then if right, then we can just return yeah, this, right? Pretty straightforward. Else, then now we want to say total minus m number of pairs, right? So we the number of pairs is going to be m. No. This is the number of pairs. And then extra is just m minus total minus m. Is that right? That's right, right? Total minus m is the number of... No. Wait on. M is greater than half of total. So then total minus m is the other stuff. No, this is right. It's just very awkward looking. I don't know. Okay, so C is right. So count and then the extra thing we could greedy because first is an intact with the second. Okay, yep. That part is still true. So we do okay. I guess this part actually is the same. And actually we don't care about the extra anymore, but I guess just to keep it consistent. And then now C extra is going to go second. Let's actually put this in the test case before I forget. And then it's the same thing, and then we don't add the both leftovers because you can match it with itself. Alright, looks okay for the inputs. We're going to have 5 wrong answers this problem. I just know it. I mean, I said it in the beginning. This is one of those problems. B put 0, 1, why? Do I have it wrong, I mean? Go first, go second. This is a second case, right? Did I mess up second? M is equal to min, extra, and both, right? I mean, that should be good enough for 1. Why am I returning 0? That's actually weird. Okay, so that's right. Right? Oh, how did I not? That was a copy and paste thing, actually. Oh, come on, Larry. This is why you don't copy and paste. Oh, I mean, I knew I would have more wrong answers, but that one was a dumb one. Copy and paste. I mean, that's why you keep it symmetric as much as you can. Okay, so why is this one wrong? This is going to be like a nightmare. Alright, I mean, I'm still on Q2. I mean, I think the idea is mostly right, hopefully, but maybe I'm wrong. There's a 7 and you so that's going to give us 7 with an extra of 4, right? Is that right? Yeah, 7, 4. And then we remove 3 of them, right? So that means that it gives us 10. 10 plus, what would I have at the end? Do I have an extra both? Is that why? How would I have extra both? Oh, I see. No, my greedy is wrong. Because, let me print this anyway, just to make sure. No, because we have too much extra. Because here we have, what is my both? Both is 7, actually. So we do take off all the extras, right? What is going on? See, we have 1 extra. Both, we have 2 both left. But the thing is that these 2 could have matched with these 2 here previously to make 1 more pair, because you split 2 previous pair to make 1 more pair to get 16. Okay, that makes sense. So that means that you do you always want to greedy get rid of the both? I guess so. There's no sense of rating it, so how do I handle that though? I mean, you could handle it, just not with an abstraction like this. Okay. Okay, so this is legit. I did consider, I mean, still mostly structurally right, but I guess I'm just really wrong. Okay, I see. Maybe. I don't know. Okay, let's try something real quick. And then we just skip the both part now. Both part, we never care about it anymore. If we have extra, we want it to be the both as much as we can. Because now we don't keep the both anymore. So the extra is just the extra. So that means that this changes, right? This is so annoying. Okay, so that now you don't. Well, if you have extra, then you want them to be both. Is that possible? I guess that's possible, but so you could have if your max value is okay, if max, this is fine, and we just have this is an extra, but we should not, yeah, okay, but this is not right, or not this part. If f of x plus x is greater than equal to 1, then we do have something to return. Otherwise, then we don't, right? Because we don't have any, then we matched everything else. Okay. Otherwise, this is okay, so then now if okay, so this is if this is max, then the most common thing is max, and that means that you basically match everything else, and this is right actually then. Otherwise, if the max is not that, then you have none left over. So just total minus m of 0. Okay. Okay. I think this is right, maybe. Yeah, let's not write that for now. We don't care about extra anymore. We don't care about both anymore. Extra is what we pass down. What is m? Oh, that's the match, so we don't. Otherwise, then now, so second, maybe I could win this differently. Second x plus x is equal to extra, and then we do the matching here. Okay. And then we just do this thing. The other things don't matter. This also don't matter. That's not even a thing anymore. Okay. That looks okay, I think. I wish they told me like in an easier way. But okay. A lot of silly mistakes, maybe. I mean, this one was, I think I just didn't, I worried about it, but I didn't really think through what would make that happen. Oh, come on. Okay, we're grinding out 829 out of 842. I did predict 5 wrong answers, and unfortunately coming dangerously close. Okay. So what's the deal here? Okay, let's just put it out real quick. So we have 17 with 1 left over. Is that respectable? Yeah, because in a greedy way, it doesn't matter whether. Oh wait. Okay. Have an extra 1. Well, yeah, that makes sense, right? Because now you have 14, just matching. Okay, so 8, 8. How does this get matched? How do you get 17 and 1? Am I doing my math wrong? No, I'm undercounting, so that should be right. 17 and 1. We make 17 pairs, and we have 1 extra BB, right? And then now we're putting second. And then now on the update, we have this thing. Oh, wow. I guess because you give the 1 to the 9 and it gives a 10, but there's a way in that this is too greedy, right? Because, okay, but that part is not so bad, maybe. It's not so good, but it's not so bad. Okay. What I'll do. That's why it's ridiculous. But our best is equal to 0. We return best, and then we just put this in the loop. There's only 2 possible ways to order this, right? So we could greedy it in both ways. So for first, second, in how do I write this? Most of this is print anyway, so hopefully we just don't need to. FS and first start copy maybe? I always forget how to do collection sets. Because we do modify things here, so it's a little bit awkward. I forget if that's the way to do it. Let me actually look it up real quick. Python counter deep copy, because that would be a silly bug to copy.deep copy. How far am I? Wow, I'm like half an hour just on this problem. But I also did not think I underestimated it. It's just, I was always hoping. Did I not have a 6? Oh, still 27, huh? So is it that you cannot do greedy? I mean, the both doesn't get used anymore, so I think that's fine. Okay. So FS. Yeah, I mean, the deep copy is not working if this is what it's print. Oh, no, that's not right. No, no, something is off here. Why does this only print once? Did I mess this up? Does it only... Why? Also, this doesn't even look right. Okay, that's not the F in a second. Oh no, that looks probably right. Honestly, I forget what it was, but I guess we can just print. Taking my sweet time. So that's right, but we don't iterate. This iteration is not working well for me. Why is that? Is it a tuple thing? No, I don't think so. Maybe. I don't know Python apparently. They should print two things. Why am I so bad? And this is what happens when I for once try to not oh, because I return count. I am dumb. Okay, this is actually fine. Maybe. I mean, I just kind of, okay. Yep, okay. But it's still 27, huh? So I didn't fix it. That's weird, right? Wow, that's actually worse the other way if we did the not. If we do it this way first. So then what is the answer? What is the constraint? Did I miss the constraint? 10 to the 5th. Because then the other way is just to... Is this fast enough? There are only 26 versions, so the other way is to maybe just do it for each one, which is ridiculous. right? Okay, fine, right? Give it a try. Yeah, okay, fine. Give it a try. I don't know if this is even working. X, oh, not X, K in range of both. So then now we have, and actually I don't even think we need to make a copy because we don't actually manipulate things. I was wrong. Well, I mean, we manipulate this, but first of x plus x is equal to k. Second of x plus x is equal to extra, because I guess we might as well use the extra plus both minus k. Right. What is the optimal? So we do get the optimal. Isn't there there was a 1 here somewhere? Or did I forget? I forgot there is a, no, there's a 0. Yeah, DC. That's the second to last. Yeah, so this should be a 1. Why did that regress? Doesn't make sense for it to regress, does it? I don't change anything. Extra plus both minus k, we give k, and then this one, right? Count 0, 0, C extra. This extra doesn't do anything. Why? Oh, I have to do a plus 1. Wait, am I just looking at the wrong thing? I don't get it. We do need a plus 1 though. That was actually just wrong. Okay, that did come back. Oh, we just never even print the for loop because I never give it to the second side. Okay. I mean, there may be some timeout issues, but for now we'll see. Okay. Wow, that is a hard one. A lot of people got it much faster and probably without. Oh, only 4 wrong answers. Yeah, baby. I predicted 5 wrong answers. I only got 4 wrong answers. Not so bad. Okay. Q do that Q2 was murder. Alright. Empty cell, mirror. What's a mirror? Top left wants to reach the bottom right. Down and right. Mirror cell is reflected, moves to the right. It is turned. Oh, so like a diagonal mirror. They could have just like 1 drawing. They cannot spare 1 drawing. Is it too expensive? Oh, and the number of unique routed paths. Okay. So yeah, mod. Okay, right. And then now, is that it? No, I mean, $500, that's fine. Do I need extra state? I think you do. Yeah, okay. And I don't like to write it this way, but I think technically it is more efficient. I think this is right, but okay. Wait. It can only move down and right. It attempts to move to. Yeah. Kind of confused about this one a little bit. Do we have a choice? I kind of want to write it this way, but maybe it's not the smart thing to do. I don't know. I guess we'll just go write it this way. I think this is more precise. Right. Okay. Otherwise, then now are we in a mirror? Mirror, then now, okay, so then direction, right, then now we, so then this is the previous direction, right? So then now, so we go to the other direction, and then dx dy is equal to directions of xy, and then we immediately just go, right? So we immediately x plus dx, y plus dy, kind of, and I say kind of because we should bound check, right? I'm about to bound check anyway, so let's do it before making a function call. Why did I write it like this? You write it the same way almost every time, Larry. Just write it that way and not accidentally. All right. Okay. Otherwise. And technically, you could do it without a mod per se, but the -1 is actually a little bit weird. But you cannot start. There's no mirror at -1, right? Or 1 1 or 0 0 or whatever. Okay, that's good. So then you just do for dx dy in direction. This is why you like to do it that way, so you can sometimes copy and paste. Okay, then total go d and x and y, and also I lied because this yep, and that's it. Hopefully. Unpackable lurables, directions, what am I doing? That's not even right. I don't know. Sometimes my mind is blank. I mean, this is fast enough, right, for the inputs, but is it actually fast? I don't know. Let's just give it a, is it always just 0? I guess so. Like, is this the worst case? Because the 1s actually makes it smaller even, right? So we want it for 3 cases. It takes 1.8 seconds. I think that's fine. I mean, maybe I get wrong answers because I rushed it a little bit, but hopefully this is fine. Yep. All right, not bad. We have 51 minutes left. We have, 3 problems so far. Not bad. Okay. I mean, after that Q2, who knew how the rest was going to go? All right, but this is maybe finally a fun one. Binary string S and an integer K in one operation, which choose exactly K different indexes and flip 0 to 1 and 1 to 0. Okay, so we flip K random string. Minimum operation to make all characters in the string, you go to 1 if not possible. I guess N is big, otherwise it's not interesting. would choose any index. Why is this hard? I'm trying to think. I don't get it. I mean, is this not just k different index, right? So you have ones is equal to. I guess it's not. I mean, I could see complexity wise. N squared is pretty easy. Ish. So then it just becomes is there a way to optimize this, right? Is there BFS, right? Yeah, BFS sounds fine, right? Yeah, right? Because I was initially thinking of DP, but which then you get a cycle, and then when you see a cycle, you're like, well, maybe BFS makes sense, right? So okay, so we have this. We don't even care about it. We want all of them to be ones, is it? So then and that's fine. I mean, it may even still be too much, honestly. I don't know if you might. I mean, is BFS still too slow? I mean, you do remove the cycles, but is it too slow? I think so. Can you optimize it like a train? Train is an idea that I associate with BFS problems, where how do you do edges? So that's the hard part of David's problem, right? Is how do you eliminate the possibility of edges? Binary search. Okay, that makes sense. Each one binary search. Okay, that's not so bad, right? We have a sorted list. Hopefully this is fast enough, because I don't know. Okay. But we actually want. Actually, we could just do it twice. Whatever. N, right? N or N plus 1. I mean, you could probably even do an odd even parity type thing. Yeah, that's an optimization. Let's focus. Okay, I think that's fine. You start at the run, so actually implicitly I removed it. And let's make it explicit. It doesn't make it that much slower. It gets a little bit less confusing. Okay. What I want N. Let's just start. Zero, right? Infinity times N plus 1. Okay, right? So we're Gucci. Let's just make this 15 with this one. Okay. Current is going to pop F, right? If current is equal to 1s, then we just return distance of current. We should also return it anyway, but and then now we go. Okay, so what happens when we do K, right? That means that we could flip Take my pencil. Okay. Did I mess this up? I have to be more careful about how I define this. I think we start at 0 actually. Okay, yeah, fine. Might as well. I once. What's this? How much? 44 minutes. I should be able to finish this within time. I think this is the right idea, and there's only parity. So okay. So then now you go to. So okay. So you either go from k, and then k minus 2, k minus 4, dot dot dot. Right. So if k is odd, then you actually want to do 1, 3, 5, 7 all the way to k. If k is even, then you go 0, which doesn't. No, you never want to do 0. That's just stupid. You're in the same place. So you go 2, 4, 6, 8, right? Okay, that makes sense. Yeah, I didn't. It's, in case you're wondering, I didn't really sketch that much on my pad. I just kind of wrote it out. 1, 3, 5, 7, like literally. But sometimes I just need a little help with the visualization. So okay, so then now for D, for delta, that's not enough. Wait. That's the number of improvements, but there's k of these because you want to do negative improvements as well, right? And also you don't want to write it this way. That's why you created the sorted list. You do a binary search on you do a binary search. How do you get a slice? Is it possible to get a slice instead? Because I don't want to do like a log n on every query that we do. Though maybe that's fast enough, but I still don't want to do it. Python sorted list slice. Like, is it faster? No, I want specifically sorted list. I'm just reading the documentations. I slice. What's the complexity though? That's what I want to know. I don't know. Maybe premature optimization. Let's go for it. Okay. So that means that we want to be able to do negative k to k, right? So we want to binary search for not negative k, but well delta negative k, but from current minus k left index, let's just say right index is equal to self delta. Oops. Bisect right of current plus k, right? So then now we go from index from wow, am I suddenly switching language? Right. In this case, we do SL of index, right? Everything in it. Oh no. I mean yes, but also no. Okay, delta is equal to SL of index. Which way does it go? I think it's just current minus this, right? If delta, I mean something like this, but I forget which is, if it's 0 or 1 or k is equal to 2 or something. I have to think it through. Okay, so if it's 3 and the delta is 3, then we're good, right? If k, this is too much stuff in my head. Okay, so let's say the current is 5. Let's just write it down. So let's say current is equal to 5, k is equal to 4, then we want 1, 3, 5, 7, 9, right? You'll never get itself anyway, so it's fine because we remove it from SL. Okay. Okay, so then now if you get a 1, is this good? Because the delta, so I think this is right actually. If we have a 3, then the delta is, wait, is it? It's not K mod 2. Delta, if the difference is the same as, no, this is right, this is right. Okay, then now we want to visit it if this is true, and well, if it's in the sorted list and we haven't visited yet, so we don't even have to check, I don't think. Right? Yeah. Oops. Next. Next is you go to distance of current +1, and then what? SL that we moved. You can't do it, Larry. Concurrency issues. But I just want to place it out, right? So maybe assert force until I fix this. But that's just my workflow. And then the other thing I have to update is Q, right? Q.append next, and we should be good. Okay, right? Did we use X anywhere? I forget. There was one problem. It was in this one where I used X as the parameter. Dot remove X, right? And then that's it. I think we also want to write here, maybe. If next is equal to 1s, then we also return this just to save time. Otherwise, we return -1. I think it's fine. Something like that. What is it? Ooh, I mean, okay, but wrong. We start with 2 1s. Oh, why do I start with? Oh no, I start. Oh, that's why I had an N actually. Okay, we wanted to go backwards. That's why. I think maybe the other way would have worked too, but no. I confused myself. So okay, so we want to start at N, and we want to get to 1 1s. Okay. I had the original done and I forgot. Yeah, I mean, let's run it real quick with times, what was it? Right. It seems fast enough. Answer seems reasonable enough. So, what's the time? I don't know why one of the screens tells you the time and the other tells you the actual thing in a useful way. Let's give it a submit. Hopefully it doesn't time out. If it times out, I bring on Leetcode really. Maybe. Unless I did something silly. Ooh, wrong answer is a little bit tougher to take though. 3. Why did I put 2? Oh, okay, I see. So I messed up a little bit. And the reason is because the way that I did it, you could choose to 3 one at a time, but that's not the case, right? So we have to, so if, okay, that's not so bad, actually, maybe? I mean, this by itself is not so bad, but maybe I didn't generalize it enough, so maybe this is just wrong, to be frank, but I feel like we have a good idea. We just have to figure out how to use it, because for example, if you have 5 things and you wanted to switch 3, can you always do all the things in between, right? I think so. So it's just this case where certain numbers are not possible, right? And we could swap that, right? Okay, how do I want to write it? How? So you have to swap 3 distinct ones. So what does that mean? Okay, so the idea here is that okay, what is the idea here? Be precise. We still have 35 minutes left. I think we'll see. The idea here is because you cannot do it this way. You have 2 and 1. Okay, I think it just depends on the current, right? So if the current then we have to figure out, okay, okay, slow down, it's fine. Basically you have to figure out the degree of freedom, and for me I just kind of got lazy on saying that if it's 3, then you could go -3 +1, or -3 -1 +1 and +3. But in this case, it's clearly not true. If you have 1, maybe you have 0. I guess we could also just put it here, but the risk here is no. I mean, I think it's fine because then it means that something is going wrong, or some short cases. Is this only the case when n is equal to n though? I'm tempted to kind of special case this out, because I think in every other case, as long as you have 1 degree of freedom. No, I mean, yes, but you may not get the minimum move, so you can always solve it, maybe. I don't even know if that's true, but because, well, yeah, because you can always either choose, but you don't have the shortest path. Because, for example, if you have to do 3 and a 4, then you can always do it, but you may not have a shortest path because you kind of cheated by doing it 1 at a time instead of or something. Okay. Man, this relationship I'm not practiced at. So we really have to do something on the delta and k and n. Not just this, right? That makes the complex a little bit trickier as well, but I think this actual because right now it just at worst doubles it, right? But doesn't tell me the running time for this for my 7 and 6 cases. Okay, think. Relationship between delta n and k. Okay, this part may be hard actually. I don't know why we said okay. So okay, if n is equal to 3, k is equal to 3, let's just say, and then once let's say is equal to 0, then you can make this to 3. If once is 1, you can make this into 2, and then that's it. But 2 into 1, and then 3 into 0, right? So what's the relationship here? So you have to find. I see. So okay, so let's say delta is, you could back figure out the delta. So delta is equal to delta is equal to the number of ones minus zeros, right? So that means that 1 plus zeros is equal, wait, what? How did I do this again? I forget how, man, I'm so bad at this. 1 and 1 plus zeros is equal to n. Wait, what? Oh, no, 1 plus zeros is equal to k, because we're changing k bits, right? And then if you add them together, 2 times 1s is equal to delta plus k. So 1s has to be equal to delta plus k over 2, and what's zeros then? Why am I so bad at this? Okay, and delta, I mean, and then zeros is just, you go to k minus 1s, and then you just check that. Okay, fine. In the current thing, right? Okay, so sorry friends, so that's the delta in the number of ones that come up. Delta equals to extra ones we get from this operation, right? And then now ones is equal to delta plus k divided by 2. And of course, if this mod 2 is not 0, then we just continue then, which I think is what this is saying really. But now we don't need this maybe. Okay, so then zeros, I always forget zeros has a E, and I am really bad at English stuff. Don't bite me please. Okay, so then now we have to check whether the current thing has enough, right? So current, if current is the number of ones, if we have enough ones, and zeros is greater than equal to n minus 1s, then we can do this. What is this again? Oh, that's just the exit condition. Am I right? Well, I mean, doesn't inspire confidence that everything is -1 though. Now it thinks everything is impossible. Actually, except for the one that except for the one that I wanted to fail. Did I mess this up? Did I go the other way by accident? If the current number of, if we have enough ones now, and we have enough zeros, and this is it, right? This is the requirement for the delta. Oh no, this is the way we changed it to. So that means that before it goes the other way, right? So okay. I still don't know whether it has a 0 now. And it bugs me. Zeros or 0. Apparently if they're both right, maybe that's why I'm confused. Okay. Anyway. Okay. Am I doing it again? So then now, well, this is still right because I just changed the things a little. I changed the formula. Okay. Did I? No. This is zeros. Zeros is n minus. What? This isn't even right. It's n minus current. So that's just wrong. Maybe that's why. Hopefully that's why. Okay. That is better. Is it? No. No, it's still perfectly wrong on everything. Oh, it is. No, I got like 1 right. That's a little bit of a solace. K is equal to 1, then what does that mean? If k is equal to 1, delta is equal to 1, okay, let's try it, right? Print current next delta zeros ones. Let's print it out instead of trying to figure it in my head. All right. Oh, I forgot that we're going backwards. That's right. Rabbit. All right. All right. We're almost there. 25 minutes. Took 10 minutes to get through this. But all right, delta. So we actually want it to be negative. What happens if it's negative? That's the okay. So that's the part where I'm not getting it quite right. If this is negative, then we have more zeros than ones or something, right? Does that come out correct? I guess so, because we don't have any current minus next. I mean, I guess the way that I wrote delta is actually not, because delta is not the k moves. Delta is the change, and I think it's supposed to be the other way. That's why it's confusing, because okay, I was imprecise because I didn't care for it at that time. Okay, so that nope, didn't fix it. This is right, but now this is wrong. Okay, so you start at 3 ones. Delta is negative 1. This is right, okay, and then 3, 2 is next, right? Delta is negative 1. Okay, we need 0 zeros and 1 ones. That's not right. That's definitely not right. Right? Yeah, that's definitely not right. We need no, this is right. I just got the signs wrong because I'm dumb. Because I don't know why I have this on the other side. Okay. Okay. Okay, still wrong though. Well, current is already 2, so why would it not return? Oh, because I reused the variable ones. Oh my, aye. Where's my if returns early statement? There's another one here somewhere. Is that it? No. This one on the okay. This one. Silly boy. Okay. Now we're cooking. Silly boy. Okay. YOLO submit. Maybe we could do an optimization with parity stuff, odds, evens. I hope I don't need to. We only have 22 minutes left. I mean, I guess I didn't test a bigger K actually. That's my fault. I did test the N is equal to 10,000 thing, but I didn't test a bigger K. I mean, this is probably fast enough or close to fast enough. But the thing is that we no longer remove all these things that we check. That's why. So we have to solve this a little bit better for the binary search, I think, because we're doing too many operations. That's a little bit tricky. Now it's correct, I think. Just a lot of silliness. But how do I fix this though? I don't know. Okay. So we have so current 0 is equal to n minus current 1 is equal to just current, right? So that means that the max delta, so it's going to be this. So given K, we can remove Z1s. So that's going to be min of this or CO. CO for the number of ones we could remove. And then this for the max number of zeros we can remove. Oops. right? Maybe. It was 2.5. Is this faster? Slower. I mean, that should at least help a little bit. I think we can put this in two sorted lists to make it a little bit better, but that's annoying. Is this always true now? No, because in this case, for example, actually, I don't know. Because, wait, is that true? No, because you could have enough zeros but not enough ones and vice versa, right? So then now, okay, so I have to do another. Well, let's. I mean, I think this is an interesting problem. I wish I didn't spend that much time on the other one. Okay, right, is this faster? Probably slightly, but probably not that much. Okay, not even. But okay. So is the number of zeros, but then you might just not have. Oh, I mean, so you have like a. It is annoying. Alright, I mean, let's do what you don't want to do, right? Let's just say odd, right? Oh, this is on index, so it should be fine. If it's even, what happens? If k is, all right, let's think through first before you code line. So if k is even, what happens? If k is even, can we put, okay. So if k is even, what happens? No, it is what you feel like. Then you don't care about half the indexes. So you could figure it that way. What was the one we get? No, that's an odd one actually. So you do hit all the cells, but that's even fine, right? So if it's even, then we automatically can remove half of these, right? So maybe we can do it that way. If k mod 2 is even, then we start at n, right? Then for I in range of n plus 1, if delta, I'm just lazy, honestly, delta is equal to n, so we start at n minus I, right? If delta mod 2 is not 0, then we just SL remove it. Don't even think about it. I, right? I mean, that wouldn't change the case for us because it's odd, but at least it makes it a little bit faster. Actually, we can even just do odd and evens. If I mean, I know I could skip by 2, but I'm just makes it a little bit easier to not think about it. Okay, right? And then now we have to think about this thing, but we don't have to even think about this thing anymore because then now, or maybe I just write it times 2, right? Do, right? Right? And then we don't even need to think about the other one. And then now, if k mod 2 is even, then yeah, okay. Let's see, right? maybe that makes it a little bit faster. I don't know. If k mod 2 is even, then what do we do? Then we still look at so the current is current mod 2, then we only care about current mod 2. Alright, and we could probably save it, but it's fine. It's only two mods. Maybe it adds up, I don't know. Okay, fine. P is equal to parity. And you cannot let's go original parity. This is too much random optimizations. But more strict. This one actually I don't feel that bad about because it's strictly more correct. But okay, bisect left. Okay, actually just copy and paste it up here. Original P. Right. Yeah, okay, fine. Right. Else. And we set P is equal to original P because we don't want to change it anyway. Otherwise, P is equal to 1 minus current mod 2 because then we want the other one, right? So then now that's also fine, right? Do I use that anywhere else? Nope, except for here. Alright, let's see if that's a little bit faster. Oh, yeah, it is. What? Where did I remove stuff? Oh, right. This is just original P, right? Hopefully that makes it slightly faster. Double this time. Alright, let's see. It's a very crappy optimization. I mean, I think that's fine, honestly. But we might still time out. What was it? 982. Do I do anything else extra? I don't know if I do any duplicate work. I think that's the thing that I'm trying to figure out, right? We can even do a count here. Wait, does this have an answer? Oh, does it time out on me too? Wow, okay. So if it times out on me, then I don't even have a great answer for this. All this work. I thought this would only trigger once. Otherwise, if it doesn't, then it makes it a lot more complicated. We did speed up twice by whatever, but apparently it's still not enough. Let's actually remove that real quick for debugging. Actually surprised that it like we have 12 minutes, so maybe we're not gonna get it, to be frank, and that's maybe fine, but I want to know this else statement. I don't know how to print it though before time limits. Maybe something like this. Like, how many times does it fail? Then we have to figure out how to optimize this, if that's the case, or is it something else? And of course, I suck at programming. It's putting out, I mean, I know that I fail sometimes, but I think maybe that's why. Maybe this has to, I have to figure out how to binary search on this a little bit better. If you have at most, yeah, I mean, that's too many. Maybe. Yeah, that's way too many. I thought that we would look at each cell at most once or twice or something. If we're doing that like multiple times, I don't even know how. I mean, it just keeps going. So that's definitely a smell. That means that this fails way too much, and we have to do a little bit better with the binary search. How do I do better in the binary search? We have the max number of zeros, max number of ones. So I think that's the two things that we have to consider. Do I not remove things right? I don't get it. Let's at least just print out a slice sample. Let's say current next delta zeros, ones, I guess. Okay, so you have a big delta, you have a lot of zeros, you have a lot of ones. What is zeros again? That's our calculation based on delta. Yeah, okay. I mean, that seems reasonable. This is our number current ones. We need this many zeros. We need this many ones. So we go an entire loop. But thing is that in theory we should remove a lot of these, right? So, so current is the number of ones. So this or this should. Why is this a fail? Because zero, we don't have enough zeros. Is that it? Okay. Let's take a look. N is. Did I mess something up? I hope so, because then I could actually fix it. Doesn't make sense to me though, necessarily. Okay, so no zeros, but we're still looping through all these deltas on the negative side. Did I mess this up on the delta? Binary search on a current. What is this again? 50,000. Maybe I won't get it, but okay. So number of ones, number of zeros. We don't have enough zeros, and yet we keep iterating. That's not good, right? Did I do this one wrong? What does these index mean? Okay, so this is number of ones. We want to remove. We want to get rid of number of ones. Okay. But we already don't have enough zeros, and the zeros are only going to go up as we go from left to right. Right? Maybe we could do something like would that be fast enough? I don't know if it's right enough, but I just want to see if it's fast enough before figuring out if it's correct enough. No, it's still too slow. It still prints too much. Though it is good that it is. I don't know. I mean, I actually don't know if it's still correct enough. I guess they don't give you the result if your time limit. That's what I was trying to figure out. Oh, nope. I mean, I think this is the general idea, but clearly I'm not doing, or because the 0 1 requirement is the thing that's messing me up. I thought I had it. I think we have to go the other way. I mean, I think they're like chunks, and I think I'm just messing it up. Okay. We could figure out the max delta, right? So maybe that's what I need to do. I was just being a little bit silly. So the max delta is going to be the number of ones. No, the max delta is the number of zeros. No, the number of ones, because we can just remove all of those, right? And I guess that's what I'm doing here. So I guess in that sense, I am right. But I need there is a stronger bound. And I think it's like a double thing. So I need to do 2 binary search, or double the amount of binary searches. Right? Because, okay, so that's all the ones. But then what's the bound on the delta? Because you have to have zeros. Because, okay, so this is all ones, no zeros, and then the 0 requirement keeps going up, right? So I think the other if statement is fine that I had. Oh, it's right here, yeah. So I think this if statement is fine. but I thought I had it or close to it, but I definitely did not. Let's see if it's correct at least. Much faster too. Oh, too much printing. Okay, too much printing. That's actually not great. I didn't expect it to be this much printing with this one. So it was fast, but it still has its issues. Also maybe not right. I don't remember it was 5. It was just time limited, so actually I don't know that I checked, to be honest. This is not that hard to check. You can just do this. Yeah, okay. So I think this makes sense, but it's still not fast enough to make it thing, right? What if I just break here? Would that also no? Because you do need to. Because this part it could it gains steam, so we have to actually gain from. Okay, so if the number of ones is greater than ones, then what are the ones that are impossible that we can remove from the index? If we don't have enough ones, so then what does it mean to have not enough ones? So the delta is oh, okay. So then the max delta, the minimum delta, I guess, is just something like this, right? Max delta. I'm close, but I don't think I'm going to solve it in time. But that is annoying. No, actually, I think I can solve it. Just I have 2 minutes left, so it's not Gucci. Yeah, okay. So for binary search, do we move a lot of things? This is the. So what does this mean? There's 2 of them. The other one is going the other way. So it goes from current minus CO to current. That's the number of ones. So what about the number of zeros? The number of zeros is going to be. Man, at this point, I should have drawn it out a little bit. The number of zeros is okay. So max 0 minus z, or the other way around, maybe. You have this thing until it becomes positive. Okay, so this is all good, but then okay, so then it's just this plus this, right? Okay. Or 0. Yeah, I don't think I could fix this in 50 seconds, but I think actually I think this is fine. Okay, yeah. It is. Well, let's leave that here. But actually, we want also. Plus. plus CZ, and then we want this to be at most 0, right? Well, this is negative, so we want this to be what? Okay, this is at most negative, but we want to make it so that okay, fine. We just wait. This way. Right. And then now we do it again. Oh, this should be bisect right. Why not? I hope. So if it's current, then it includes current. Is that right? Maybe that's fine. We just have to do it this way. This is actually not given right, but oh. Well, okay. So we have this or current plus someone like that. The current would not be in there anyway, because we should remove it, so that doesn't make sense. But I worry that we are off by 1 on the indexing after removing the first time. I don't. Implementation's a little bit tricky. I think this feels a little bit better. Yeah. Let's 20 real quick. Might have like, oh, that's not what I expected actually. Yeah, that's what I was worried about. That the indexes overlap and then you have like weird things. Actually. Oh, I mean, I'm dumb. Why not in list? No, that means that we already removed it. Okay. Maybe that's fine. It's a little bit awkward though. Wait, is it fine though? Why would that be? We have 0, 1. Why would we put in the removal twice? Remove, okay. We do put in the remove twice. Oh, because of the second time in the loop, but oh, because we don't clear remove. Okay. Okay, that's what I expected. But we can take a look at to see why. Where's my print statement? Huh? That's weird. I guess I don't end up using this, but I do use the idea, obviously. I mean, Oh, because of this we removed, and then as a result, okay, fine. I see. That's why I had it outside, but we want the removal to only happen once, I suppose. I mean, we may do a little bit duplicate work, but I think that's fine, maybe. Okay, that's too much printing, but is it the right answer? Okay, we don't know because there's too much printing. Where is my? Oh, here it is. Ah, okay, right answer. And oh, blazing time. I don't know if it's right, but it's blazing time. Let's see if it's right for this one, or at least fast enough for this one. It is the wrong answer though. Oh, actually, well, wait, did I say it was the right answer before I put this? Because I thought I ran it. I mean, I ran out of time. That's why it's telling me now, but maybe I just missed it. Okay, I guess I didn't look at it. Well, it got wrong answer on this one, but it got wrong answer really fast. So that's always nice. Okay. Maybe this is just not my problem, or the math is just a little bit off, which honestly I wouldn't be surprised. I mean, yeah, just a little bit off on the math, but okay. So we have 4. We have 0, 1, 2, 2. Don't know what that means, I guess. I guess for this actually is we expected 2 because for 3 we can do. For 3 we can do. I don't know what the indexes are, so I guess I have to do SLP. Okay, so that's pre-remove, so you have 1 and 3. From 4, you can do to 1 and to a 3, which sounds right. Yeah. Is that right? Maybe that's right. I don't know. Can you do a 3? Yeah, 4. No, 3 is not right. So it's still not right. Right? Well, it's just an upper bound, so we just use it for setting. So we have four things. You have k is equal to 3, so you go to 1, right? And then now you have 1. Can you go to 2? The sorted list is 0 and 2. Why can you go to 2? 0, 1 is not inclusive because I suck. Maybe? What is this number? So, okay. So, I mean, this is actually a good way to debug. Or this is a good one to kind of debug on because then now we can kind of visualize these a little bit better. We have 4, so this is going to be, this should be 1, right? Well, I mean 1, but 1, I guess this is not the one that it is having issues with. It's on the other side, which I didn't really think about that much. I was kind of just, so this number should be correct. Well, I mean, it shouldn't be correct, but if it's correct, it would make my life easier. Or we want it to be correct. The other one I am confident about, like this one, it should be right. I mean, it's just the number of zeros, right? In the max case. But okay, so then it goes to 3. So 1 goes to 3 is not right. That's a min. Why does it think you could go to 3 with 3? With 3? No, with 1, 1. You can. Okay. I have to draw again. Or I have to sketch again. With 3 zeros, 1, 1. you can go to, from 1 you can go to 4, obviously, maybe. You have 1 0, or you use 1 1 and 2 zeros to go to +1, so you go to 2, right? Yeah, I mean, so 0 1 is right. Okay, and here we go from 3, so we already skipped the 2, so this is off by 1 or something, maybe. Yeah, that's not right. On the positive side, that's what it should have been. Why am I wrong on that? Okay, so you have 1. This is the number of zeros, and then minus the number of ones. Well, this just turns out to be 0, right? Current minus this, so I don't know how that makes sense. What is the min? This is so hard for me. Clearly, because this is basically what I've been working on for 30 minutes. The actual algo part, I'm pretty okay. The math part, I'm so bad. Okay, so you have 1 0 3 z's, so you are able to go to 2 because number of zeros. I don't think the f min makes sense here actually, but I just kind of copy and paste it. Well, maybe it still makes sense, but I don't know. Maybe it doesn't. Basically, you can go +1 by picking 2 zeros and 1 1. So what's the well, the minimum is going to be +1, I guess. And the number of 1 is just restricted by... Okay, what are the number of 1s we have? We want to add, right? So we add. Are we ever restricted by 1s? Well, yes, if you have if you don't have enough delta or whatever. Yeah, okay, that makes sense. It's basically the case here. I mean, maybe in reverse or something. So then how do you have enough 1s? I'm so tired. Basically we want this to be +1. I mean, this isn't a minimum, because this is supposed to be one of the min bounds, so this is wrong. Right? Okay, so what is the minimum bound? And the minimum bound is, can you do 1? Can you do 3? Can you do 1 is if you have... You can always do... Okay, so I think I'm thinking about the positive side wrong. Because if you have current, you can always do can you Larry? Up to current number, which is okay, so basically you have current is the number of that means you can do so +1 would be if the number of zeros is more than the number of 1 by 1, which means I don't know. Like this would be right if we just do this, right? For example, let's double check to make sure that our code isn't too long. Okay, it is too long. Oh, actually, that's just because of this side. Actually, no, this is the odd case, so this doesn't even come to play. So it's still wrong with this. That's actually not great. Unless this is the case. So we have, okay, so this is still wrong. So this is wrong and this is wrong. We have to try to figure out the double binary searches. The constraint is the part that I'm struggling with a lot, clearly. I mean, this is wrong for Q3 anyway. Or 2, I mean, case 2. And the other one's wrong for case 5. Well, case 5 is a big case, so it's possible that both are wrong. Can you do 1? Can you do 3? I guess that's the question, right? Can you do 1? One is maybe I just need to write it out. The count of zeros minus C of 1, 3, right? So what happens if either we don't have enough zeros or we don't have enough ones? We will probably always have enough ones as it gets bigger. We just want enough zeros at some point. Fine. Because we're going from left to right, we are always increasing our zero needs. So maybe this is fine with this loop, because at some point that's fine, but then now we have to maybe that's fine, because we'll just because that's our zero needs, right? So ones don't matter that much, right? Hopefully. I think this is fine, because we always have enough ones, and if the first one doesn't have enough zero, then we could loop back. I guess we could do it the other way too then, right? I mean, yeah, okay. Okay, now, oh. What is that one? I actually thought that would be right. Oh, I still need to, no. What? No. Why is that one? I mean, this is just loops, right? Oh, no, okay. Maybe I just missed copy and paste somewhere. Okay, so this is right, but we want to go backwards. Because going backwards, then we can increase our needs. And also, in fact, then I'm just doing it in a dumb way, because I don't need binary search. I just go search for the current index, right? Okay. I hate this, but okay. Yeah, we're gonna do it that way then. Yeah, okay, fine. I mean, I only hate this because I wish I thought about this before a lot of this pain I did. Because if it works, and I don't know that it does, but if it works, I would feel like I should have known to do this a while ago. Original P. Okay, because then now we want to write it in two places, right? So here we just go C index left is equal to C index right. There's a bisect left, so that means that when we go right, I mean, I think it doesn't even matter. Yeah, because eventually this condition will be wrong, and then we just break. I double check about these conditions actually. Because it keeps going, but okay, so it keeps going, and then either we want to. Is there a donut? Okay, going from left to right, you always have enough zeros until you don't. You start with zeros, but then if you don't have enough ones, that's when you are having an issue, right? Why am I so bad at this part? You don't, but yeah, it doesn't start at the middle. So maybe this isn't quite right actually. That's because I think there is a donut. It's just that if you run out of zeros, you already passed the donut. Is it? Yeah. Eh? Well, you passed this. Okay, so zero side of the donut. Man, if I was good at math, this would be I would be done. Because basically it's just two segments, and then you intersect them. Why? Why was it so bad? Maybe I just need to draw it out. I'm just dumb. I mean, this is so stressful because I feel like I've gotten this bit. Also, like the last part, I cannot get apparently. Okay, so you have, you have current, and then you have current minus k, and current plus k. Okay, we established that, but that does too much work. So then now you constrain, right? Minus k or minus delta. Let's actually d for delta. Minus delta means that you have d is equal to 0 minus 1s, right? No. You need 0 zeros because you're going down for delta, right? Well, it depends how you want to define it. So I guess it is always just 0 minus 1s actually. Because then now delta is negative. And then and it goes all the way to when you don't have enough zeros, and you don't have enough zeros when, well, you know what your current zero is, which is n minus current. So n minus current is your number of zeros. So then now z minus and then the number of ones is going to be minus current. Oh man, did I just dumb it up? So it's going to be n minus current times 2, or n minus current minus current. So what is that? That is that's one of the bounds, but I don't know which one because I'm just brain dead right now. For example, if n is equal to 5, current is 2, then that means that you have 1, 2, or 2 ones, 3 zeros, and then the lowest that you can go well, it depends on k. So I need to get k back in here. I guess that's part of the confusion for me. Okay, so that's 0, there's 1s, but then now you have k, right? So that is, you have the delta is equal to this. I mean, I have this formula here. Literally, I'm just rewriting it. K is equal to 0 plus 1. Then you have, this is the number of zeros. And then what is the max? I see. So we have to find the zeros of this function, I suppose. Right? Man, I am bad at math. Equal to delta plus, I mean, okay. So delta is equal to 0 minus 0, k is equal to 0 plus 1s. And then 2 times 0 is equal to delta plus k. Right? And then you have this thing, I guess, which is what I already wrote. Okay. But then now how do you minimize this function? Well, if this is 0, no, I mean this works, but then now we have to figure out how do you, like, what is the like this fails because it doesn't have enough ones, right? Because otherwise, so this always passes because this always breaks. So then now current is -1. So maybe I just need to print this out because I am just being dumb. And this will time out, but that's fine, maybe. Oh yeah, now I don't even do, my LR is weird, so it doesn't do anything. What did I have it before? In this one, it was already 45 minutes ago, and I haven't even. I just need a couple. Oh, that was before I tried to do it in the craziness way. Okay, fine, just wait. And this will give me output limited. Didn't it used to at least give me the output that is limited? Now it just doesn't print anything anymore. I really wanted to see the first few instances because I am pretty dumb. Oops. It used to at least show you the output a little bit before telling you that you're dumb. I guess the output is just actually very long because sorted list is very long. Maybe I don't need the sorted list. Where did I print that? Actually, it's here, not. Okay. So this failed because our current is 581. Really? I guess 4 is n, and let me just print out n. I'm actually also getting tired. Okay, so just one iteration. Well, I mean, it's BFS, so the first one probably none of them fail. So this fails because we don't have enough ones. So to get enough ones, it just has to go down by like 2,000, and zeros goes up by 2,000. So what is the maximum delta here? Okay, so you have all them. How do? So, okay. We have enough zeros. We don't have enough ones. How does this work? Lower bound is negative. Oh, I forgot about k. What is k again? K is a big number. So if k is a big number, did I misread this thing? No, this is n. So the first k probably does a lot of stuff, but so then this is the second loop where it actually fails at 581. 581. The max delta is makes sense because because we only have 581 zeros, 581 ones. Why am I so bad at this? I can't figure it out. Oh my god. Okay, so that's, we think that's the maximum, the minimum delta, but that's because at 581, where is this? I think it just can't go under 0, right? So it goes, so it tries to remove all of them. It fails because we don't have enough ones, which is true. But then how do we decrease this to what is the delta? So okay, so we could solve for this, right? So we have the current is the number of, okay, so plugging it back in, we have this is the current. If that is the max ones, then that means that we need at least this many things. right? And this many zeros. No, is that true? I think I'm just counting this in a weird way because it tries to go to 0. We're not trying to. We have the number of zeros now, but the order of zeros we go are increasing. So these are all routed on the 0 side. We're just trying to trim this down on the 1 side. And on the 1 side, I mean, well, this branch is useless. Why am I so bad? Because it doesn't go, because it goes over, right? Yeah, because you need more 1s than 0s, and there's no chance for this. Okay, so that means that on the that means that, well, it's just impossible to have negative. That's 1. Because for that, then you actually have to have at least positive 2800 or whatever it is. Right? You do this. But, okay, so then, okay, I see, maybe, I don't know. Okay, so then now, minimum delta is equal to the maximum once you can, okay, minimum delta should be 0 minus 1s, and the maximum number of 1s we can have is this, which means that by definition, n minus this, or not n, k minus this, oops, that's not k minus this is the number of zeros, and that will give you the min delta. Is that right? And maybe this should be, I don't know if the sign is right. Something like that. I have to fix it in the actual place. I mean, the other place too, but not for this example. Okay. Is this a little bit better though for this one? No, it just returns -1. What is min delta? Negative. Min delta is -581. I guess that's right. You should be, no. 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 Because those are the number of 1s you have. So this is the number of zeros you have in this case. So then it's actually, this is max 0, and then this is max 0 minus CO. So bad at math. Hopefully just today. Okay. I mean, I skipped a lot, so that's good. Still a lot of failures, which is not great, as you know. Let's take a look at the running time. I think we had it better earlier, but I think that was also wrong, so I don't know. But well, actually, let me double check, because the print statement sometimes takes a long time. So there's only 1,000. So maybe that should be fine. Honestly, we don't even need this. But we had it faster before. Okay, we should have 0 failures if we did everything right. So let's go, and so I'm just using this to kind of think about the cases. Okay, so this is once, this is again. Okay, you have 1 1. Did I not get? No, I got it in both places. Okay, let's print out min delta. Min delta is 4349. That sounds right. So then why is it trying deltas of 2? Oh, because I have this min of this. Okay, well, let's see if that works. That'll be great if it does. Okay. Now we're going super fast again because, I don't know, maybe I actually did the math better. Alright, let's YOLO submit. Oh, I guess I should have ran the other case because I have it. Okay, wrong answer, but fast. I hate how Leetcode just gets rid of my things because I ran out contest time. I really wanted that timeout case. Okay, what is this again? 1 expected 3. Why is this giving me 1? Why would this give me 1? It doesn't even make sense. I guess this line it is. Okay, so you have 3. Next is 0 with a delta 3. Okay, that's. Wait, what? Oh, do we not bound this by k? No, that's in k. So why is this weird? Current x delta. Why is delta bigger than k? I mean, something went wrong. Okay, I mean, something always goes wrong, but and it just terminates, so it's hard to tell. But okay, I mean, I think this is the one that we need. Already have all the debugging set up. Does it not print anything? Oh no, it prints 1. Do I terminate early? Somewhere? Before I even get to print this? Try again, just in case I don't know, made a change afterwards. Huh, there are other print statements? Just 1 number? Am I getting confused? Yes. Oh no, output is not the standard out, right? Okay, so that's just the output. Okay, no. But why would I not? What would I do to return early? I guess here. But that should still print here, right? Or here. I'm so confused. Did I mess up like the initial configuration? Do I have an early return that I am? I mean, that's it, right? And all of them I have a print statement before. Did it just ate my print statements? Because maybe I print too much here or something. And it's like a Leetcode weird special. Unexpected Leetcode behavior. This is oh yeah, okay. So that was the reason. That's actually pretty bad. That it depends on your order, and I think this is just an empty. But okay. Okay. Do we look at 0 and 2? Why would we look at 0? Left is current min delta. We don't have enough ones, but no, we always have enough ones. But we go backwards. We don't have. Why? Oh, what is min delta? Okay. And this is some old thing. So much time on this. I feel like I'm not even solving problems. I'm just like being dumb. Okay. Okay. -2 min delta is really big. Really small rather. What is min delta actually? I guess you could figure out it's like 5, but why is it 5? Or -5 rather, but yeah, why is it -5? Okay, let's see. We have 5, we have 0. No, you have 1, you have 3, so that's -2. You have 1, you have negative. Okay, so let's try again. Man, I'm tired. 1, you have 3, so this is -2. Yeah, this clearly cannot be, so maybe we do max of this and 0, which doesn't make sense. Okay, I mean, that's definitely wrong though, but min delta is at least slightly less so, maybe. But also, it still shouldn't go because we have this if statement, right? Well, even if we do calculate it, delta is equal to, yeah, so we have here, we have current, we have next, delta, zeros. Oh, well, that's definitely wrong. We should not have -1. So that means that something really is wrong, though we knew it. Huh. Why? Am I doing min delta wrong? So okay, so this is the maximum z, maximum 0 that we can do. So then the min delta would be, why did this, or oops, or what we had before, right? How do I write this? We do need like we want to, okay, so I guess it's maybe this and current. I mean, I guess any current minus f min of k. and the number of ones. But that's not right either, I don't think. Oops, where did the Y come from? Oh, this is F max. That's not right. Why is the map such that I am dumb? Okay, this is max Z that we can support, right? This is number of ones. This is the, was any more, is this the max or the min? Maybe I confused myself a little bit because this is the min zero. Yeah, no, this is actually the min zeros that we can support, not max, because CO is the max ones that we can support, right? That means that min delta is going to be this thing. Yeah. But then I don't know why that is wrong. Why is that wrong again? 3. Why can 3 go to 0? And we could have an if statement here, but it just means that there's more things in the fail bucket, and then that's why I'm trying to figure out why it's not. Okay, next. Delta, why is delta -3? This because we're, well, this is just not bound by k, really. I think that's the bigger issue. Min 0 needed. Min delta. I just say we want. If it's negative, what does that mean? Is it okay to be negative? Yeah, it's okay to be negative. You just have a lot of ones. Yeah, it's okay to be negative. This one is okay to be negative. But then now you have max Z is equal to or just K, kind of, right? It max Z is equal to max of or min of Z or K. So then now this is the thing that we had. Am I going the wrong direction? No, this is going plus. Going down is actually going to be 0, right? So, yeah, no, I just suck at math. Like I feel like this is not hard enough for me to spend an hour on just like this particular part. I think this is also like if I wasn't recording, I would probably take a break and then come back without looking at the answer. But because this is very tractable, I mean, I think we're pretty like even the okay, well, Leetcode is whatever. But even the solutions that we were close on, like they're fundamentally okay. It's just I'm really bad at the actual math, and I don't know why. I'm bad at math. I mean, I know why I'm bad at math. I haven't been practicing, but still. Yeah, like how did I get a formula in which I get a negative number of 0? All right. In the interest of me just making sure that I'm not doing something really dumb, I'm gonna peek at some, oh, Alex. And then to just to go. Okay, this is actually much dumber than the way that I did it, and I don't mean dumb. I mean dumb in a good way for being able to come up with this. All right. Well, I don't know how to solve this problem then. I mean, I mean. I mean, some of this I was thinking through, but I don't know. Is there like an answer that isn't like crazy? Man. Maybe I could have been. Maybe I was able to do it. I thought there may be a solution like that, but I just wasn't confident. But because I thought, you know, I thought I could just implement it out. See, this is the way that I was thinking of, right? But yeah, I mean, this is basically what I have, right? Actually, yeah, it's very similar because even did the parody thing. Why is mine so much slower? Did I do something wrong? I guess this part is probably the part that I am confused about, and that has all the issues as a result. Yeah, I mean, what is M again? I mean, I think this is basically what I want to write, but don't know how to. I mean, I think the idea is, yeah, and I try to write it. I think this is what I was trying to figure out with respect to um, doing the two binary search thing. I don't know. Yeah, I mean, did I miss a thing? Why is this 0? Oh, it's all ones. I guess she just did the thing with counting number of zeros or something. So maybe it's like the same but opposite or whatever. I guess that's the wheel bounce, and I just couldn't figure it out. I mean, I'm gonna cheat now. We might as well, because this is it's just maths, and I couldn't figure it out, which is way upsetting. But it's still like maybe I'm missing something, but yeah, and I don't have the 0 because I do a binary search on the array. And when you do a binary search on the array, it doesn't matter. Because if it's 0, it will just get the next thing, that's why. But they actually she changes it to another thing, so yeah, maybe I was just maybe I just don't know how to do it. Let's see if I can understand. X is the number of zeros, okay? And then we push X to okay. Let's walk through this. I mean, might as well. I'm already cheating. Might as well try to figure out how to be a little bit smarter about it. Let's learn together from her code. I mean, I got most of this. So this is zeros, right? So we can This is how I learn code, but if you're curious. But I also like spend a lot of time, as you know, studying my own code, so that gives the reference, right? So Q contains the number of zeros, right? And visit of x is equal to distance at x number of zeros. And it's not like I don't know how to do it. It's just it's frustrating because I just couldn't get the formula. It's just one of those things. And I didn't even. I don't know if I could have tried hard enough to like. I don't mean that in a confident, arrogant way. I just don't know whether I can try hard enough to even get this. Maybe I could have if I like went pattern hunting or something, but I don't know, honestly. Because I mean, but also to be honest, I didn't know because I thought I had a solution, and looking from her solution, it seems like I did. It's just that I can't get the formula. Okay, so what is L? L is x is 1. Let's denote this again. X is the number of zeros. What is M and N? N is the size. Oh, M is K from our size of the array. M is the number of bits to flip, right? So then what is L? Then L is, man, this is very confusing the way it is written for me. Like what is, why, how? All right, what is R? Maybe that's a little bit easier to understand. R is the number of bits to flip. So, okay. Because you're trying to get rid of, so what she's doing is she's trying to get rid of zeros from the entry thing. So R is just equal to the number of zeros to flip off, which is limited by M, of course. So then this is maybe the number of ones to flip off. But okay, so what is number of ones? Number of ones, and I think that's what the plus minus is. It's just that it is I don't know, right? So the number of ones is going to be equal to n minus x. So then subtracting this is basically what she's doing. So then, but then this gets flipped because, I mean, that's just how it is. Yeah. So then L is just the number of ones to flip off, which is limited. No, that's it. I mean, limited by M as well. I think that's the 0 point, and this is factored in, right? Because this is the number of ones. Wait, is it? This is the number of ones. M is the number to flip. So L is not that. L is the min number. The min number of zeros to off, maybe, which is limited by the number of ones. Is kind of what the thing is saying. Because if maybe, I don't know, question mark. All right, LL, what's LL? I mean, funny enough, a lot of this, like we kind of did, this optimization. I don't know how to get, this is the format I couldn't get, and I still don't know that I understand. I mean, it is the bound of the ones and zeros, but I don't know how to come up with that formula, right? Left bound of the things we can reach, right bound of the things we can reach. right? But I don't know that I know how to get this one, right? I mean, if you want to do plug and play, I mean, maybe I could just to kind of get an AC and then, you know, but, I guess this is, yeah, I mean, I think that's fine. You don't need a lower bound. I mean, yeah. I guess that's actually a cleaner way of doing it too. Basically, yeah, we don't need a bisect right because we just keep going until we run out of zeros anyway. I mean, you could have also have done it that way, running out of zeros, because eventually you would always run out, so you don't actually need the right bound. So we could write it that way. Let's actually do. So this one may not even be necessary, though. For symmetry reason, it looks nice. I'm just not, yeah, not great today. All right. Well, right. So we have this thing, right? We can say, while index is less than, while true, you can actually probably do it this way. Oh no, you have to do it at the end. Because this will eventually terminate it, so that's why it's fine. It's a little bit awkward, but that means that you have to set so index is equal to left. Well, this will terminate it, or we run out of bounds. So I guess maybe left is less than length of SLP, something like that. Right, so then now we just have to figure out what the bounds is, and what we did not get is this LL thing, which we can just put it in. Why not? Plug and play, right? So L is equal to, as we said, we actually put the comments, and I didn't need the comments. But okay, so let's just use shoot it with just 0. This is our K plus, I think there's just ones, right? Oops, ones, which we already did. And then R is equal to min of K, and I have to remember that she did it the other way from, so maybe some of this is a little bit off. Like in terms of ones and zeros, because we're going from 1 to 0. Actually, I guess we actually end up doing the same thing, except for our starting is off, so I think maybe this is fine. Starting and end states are different. I think that's the only thing. What is x again? The number of zeros. So yeah, min of number of zeros. This is weird. Minus. Yeah. Okay. And then LL in this case would be equal to K plus, what's M again? No, M is the K. So what's X again? X is the number of zeros. Oops. Plus K minus 2 times R. If it infinite loops, then that means that I have done something funky. Oh, well. That also means I've done something funky. Like not incrementing index. I meant to do that when I had this here, but I just forgot. Oh, is that that? No. Oh no, it's not. Why do I? Oh, well, this is true, not that. Oops. Okay, that's not great. But keep on getting like random spam course. Actually, it's remarkable we got any correct at all, but okay. So for index, next is, oh yeah, we look at the value. We do some checks, but why is this wrong? Okay, so we're just not looking correctly, maybe. Well, we don't print anything, so something's really wrong. I'm so annoyed. So annoyed. Print is current. So we do print that. We print, where's my next print? Print 4. The current, yeah, we start at 4. We try to go to 3. Can we go to 3? No. What? Why would you go to 3? Okay, so then now where's LL? Because we're trying to go from small to large, so that means that it starts at 3. But now for 4, you should be able to go to 1. So this is wrong, or at least I'm not. Can't even copy someone else's code correctly. Did I change something else wrong? No, I mean their code is very let's try to figure it out. 4, 3. No, I mean it's before this. This is why. So L is. It is correct interpretation, right? Unless I did something else wrong. No, I mean everything seems right. Annoyed that she uses totally different variables for no reason. No, I mean this should be right. I don't. 4003. Huh. Alright, we can print it out. Let's see. What are we using? But she doesn't go from. Does that matter? I mean, it shouldn't change anything, but we may change the debugging, right? What is L? So this is 0. Why? All right, let's just copy it exactly. So M is K plus the number that we're doing, which is current, minus N, which is just N actually. And then R is equal to K and current. No, the L and R is still. Wait, no. No, L and R is still. No, L and R is different. So maybe I did copy it wrong. Why is that? Huh. What did I thought this was? Current. Let's see. Minus. Maybe I misunderstood that one. I don't know. Okay. Because this definitely changed. Because then now, yeah, it is -3. So then now it goes to 1. But then now after it goes to 1, doesn't do anything. And this prints only because yeah, because it breaks. I think that's fine. But then it goes to 1. But then now 1. Being at 4 is not right, because you can certainly go to 2. Flip, yeah, you could flip one of the 1, and then so why is that? How does this adjust for it? Maybe it does change the answer. Because the 2 goes to. Actually, 2 goes to 1, goes to. No, it goes 2 to goes to 3, right? So it's the same idea. Yeah, 2 1s. Oh no, this I forgot that mine is wrong. She's doing it from the number. Oh, that's probably why I got confused. Also, I forgot that. Yeah, she was doing the number of zeros and I'm doing the number of 1s. So maybe we have to flip the signs a little bit, because the values don't make sense necessarily. Something like this. No. I mean, it's either one or the other, right? Like, this is better. Okay, but 4 going to 3. Is it what I'm pointing? Yeah, 4 going to 3 is not possible, right? Yeah, 4 1s. You cannot go to 3 1s. Oh no, this goes to -3. That's why it is. It sees the 1 and then it goes to. Okay, yeah, search for 1. No, that's fine. I forgot this is a different thing. Those are L and R's. But then now it goes 0 and 1. I can't even cheat correctly. Feels I think this is just one of the things that some problems you're just gonna be bad at it. There's no way around it. But yeah, and maybe this is one of those things. I need to go for a run, but I've been 3 hours on this problem. Is very frustrating, because I have most of it right. I just cannot get the formula for the life of me. In this case, maybe this as well. I don't know. Why not at this point? Apparently. Alright, now that I've cheated, hopefully my cheating is paying off. Do I have any print statements? I have a lot of print statements because a lot of things went wrong. Alright, let's YOLO submit. But, so okay. So I mean, at the end of the day, I feel like I did okay on the algo part, not so okay on the the math. I still, I mean, I'm gonna, you know, now take a break, but I'll have to dig into like what this is for the explanation video or whatever, because this is mythical to me, I think, for now. I mean, everything else, like you saw, like I already had it mostly set up, and you know, but I think I just wasn't able to get the math quite right. And in fact, I thought there's a donut in that I had like, you know, the left and the right, but I guess I was very wrong. Because apparently it's just something like this, and I don't know. It's just very frustrating. I have to figure out how to derive this, because I tried for like 2 hours, more than 2 hours, 3 hours almost. But I have to go for my run, so that's all I have for today. I mean, overall, an okay contest. Q2, I definitely spent a lot of time on Q2. Just wrong answers. But yeah, I don't know. It is what it is. But yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.